All right, welcome back. This is 2.2, Simplifying Radicals. All right, so in our last lesson, we did a little bit of simplifying radicals, but all of these radicals had perfect squares, so that makes it really nice. But in this class, these aren't going to be perfect squares, okay? We're going to start with the real number system, and then we will go to the complex number system, which will include imaginary numbers. All right, so let's get started. So there's this list of our steps to simplify radicals. You can refer to that when you do your homework and your notes, okay? So the first step, get my red, I kind of like my red. So the first thing we do is we'll do a factor tree. Okay, so for each step of the factor tree, we want to find two things that multiplied to give us the original number. Okay, one way to do that is just to divide. What can we divide this number by? Okay, so perhaps in the past you talked about some tricks and helps to simplify, but I think one of the easiest things is just to start dividing the number by a prime number, okay? And remember, 1 is not prime. So when we're all done, all of our branches of our tree, well, all of the ends should be prime numbers. All right, so perhaps since the last digit is even, then I know that we could divide it by 2. So perhaps 2, and then it would be helpful to have a calculator when you do this. I mean, obviously you can do this by hand, but it sure helps. Okay, so 196. Then we'll do another branch. Divide that by 2 again, you could do that, and you'll get 98. Do that again, we'll get 2 and 49. And what can we multiply by? What can we divide 49 by? Well, there's only one thing, that would be 7 and 7. Okay, so that's the first step. All right, and again, all of these branches, all these leaves of this tree are primes. Can only be divided by 1 in itself. Okay, so next step is to group like numbers. Because this is a square root, oftentimes we do not write a number, but this would be, if you could write it as a number, that would be a square root, would have a 2 here, versus something like a cubed root, which has a 3. Okay, so since it's a square root, we are trying to find groups of 2. So there would be a group of 2, that would be a group of 2, and then this 2 would be all by itself. All right, so basically what we're doing here is we are doing the square root of 2 times 2 times 2 times 7 times 7. Okay, but we know what the square root of 2 times 2 is. Okay, the square root of 2 times 2, well, that's the square root of 4, which is just 2. So that's why our next step is to take, it says here, groups come out. So since we have a group, we can take that out by taking the square root of that, which just gives us 2. So the square root of 2 times 2 is 2. And the square root of 7 times 7 is 7. Okay. So we take that there, we take this here. All right. And then anything that's not in a group stays in the rational, or the root. Okay. Okay, so then we can simplify. We can get 14 square roots of 2. And that would be it. I think that's everything. Multiply everything inside the radical and multiply everything outside of the radical, and you're done. Okay, my understanding is that you've done this before. So a lot of this is just a review. I think maybe it was in 8th grade. All right, for this example, we're going to put a 0 on the end. Okay, otherwise you can't simplify it, you just stop. So we're going to put a 0 there. So we'll use our factor tree. Perhaps we can take out a 10. Because it ends with a 0, we know that we can divide it by 10. And that would leave us 132. Okay, 132, let's do the 10 first. That could be 2 and 5. And then I know that we could divide 132 by 2 because it ends with an even number. Okay, so 132 divided by 2 gives us 66. And then we could do 6 and 11, and then 2 and 3. Since it is a cubed root, we want to find groups of 3. So maybe I'll just do a highlighter, something like this. Okay, I don't really like that. We'll just do something like this. Okay, so we have a group of 3, so that will come out to, we can't take anything else out, so we'll have a cubed root. This is where people will mess up or leave something out. Okay, if it's a cubed root, you need to keep it as a cubed root. If you don't have a 3 there, then it would be a square root. Okay, then everything else stays in, so we have a 5 and an 11 and a 3. Okay, so that gives us 2 cubed root of 165. All right, so if you can, pause C and D and do that yourself. So here we could do a factor tree. One of the tricks is if you add these 2 digits together, that would give us 9. And since you can divide 9 by 3 evenly, then we know that we can factor out a 3. So that would end up giving us 21. And then we'd have 3 and 7 groups of 2, since this is a square root. Okay, so we'll take the 3 out. We already have a 2 out, so we'll just multiply that to the 3. Square roots of 7, so that'd be 6 square roots of 7. Okay, D. Okay, there's lots of different ways. Some people like to start with like 5 and factor that out. You could also factor out 25 and a 9. Okay, and that would give us 5 and 5. 3 and 3 groups of 2. Since it's a square root, we already have a 6, so we'll have a 6 times a 5 times a 3. And since there's nothing else, there's nothing to keep in the root, we will just throw it away. Okay? So it would end up getting 90. Okay? And you could plug that in your calculator to verify, because you can do that pretty much whenever by just plugging in your calculator. I mean, even here, since it's going to be irrational, you could plug that in your calculator, and then you could plug that in and make sure that they're the same. Okay? But we're also going to be talking about variables. And variables, you can't plug that in your calculator. I guess you could do the number part, but you'd have to do the variables by themselves. Okay? So before we get into this stuff at the top, let's just start doing a couple examples. So we'll do our factor tree. We could do 2 and 64, and we could do 8 and 8. Okay, here's kind of a trick too. If you find a group of 2, even if it's not prime, we can take that out. Okay, if you didn't know that, you could just keep going and do 2 and 4 and 2 and 2, 2 and 4 and 2 and 2, and you would take out a 2 and a 2 and a 2, but 2 times 2 times 2 is 8, so you end up getting the exact same thing. Okay, so I'm just going to leave it at 8, a pair of 2's. Okay, now we have x's. We can write that as x times x times x. Okay, we have 2 groups of x's, so we'll have 8x times x, which is x squared, times the square root of what is not in a group, which would be 2. Okay, next, it's a cubed root, so make sure you notice that we're looking for groups of 3. So 2 and 36. 3 and 12, 3 and 4, and 2 and 2. Okay, groups, well, we don't have enough 3s, but we do have enough 2s to make a group. Okay, x's, we have x times x times x times x. Okay, groups of 3. So we'll take out the groups. We'll have a 2 times x times the square root of what's not in the group. So we have a 3 and a 3. So 3 times 3 gives us 9. And then we have an x. All right. Next, make sure you try and do these by yourself. Could do 2 and 6 and 2 and 3. X, X, X. Make a group of 2. Make a group of 2. Okay, we already have a 2 out there, but we have another one. And now we have an x. Square root of 3x. So that would be 4x, square roots of 3x. Okay, so let's go back to above here. Okay, so it says variables change things a bit because variables can be positive or negative. It is sometimes necessary to restrict your answers to only positive numbers. To do this, you use absolute values in your solution. Okay, so we want to figure out when do we need to use absolute values. Okay, here's the conditions. 1, we have to have a even root. Okay, so even root example would be something like a square root, or a fourth root, or a sixth root, anything that has an even root. Okay, 2, the variable out of the root has a odd exponent. Okay, so for example, some odd exponents could be something like x, or x cubed, or x to the 5th. All right, so looking at that, let's look at some of the problems we've done. See if we need to have absolute values. Okay, so for e, since it's even here, the exponent is even, and the root is also even, we won't need it. Our next answer here, it is odd. Oops, and I forgot it there. But the root is also odd, so we don't need it. All right, but this one, we have an odd exponent, it would be a 1, and we have an even root. So here we would have to have an absolute value over that x. Okay, so let's do a few more examples. Remember, if you feel like you're comfortable, you don't need to do all of them, okay? But I think it's a good idea, okay? Actually, you probably should, because you don't know what we did in class. And if you want to get graded on your notes, then maybe you should just do it all. Anyways, okay, here we go. We could do 5. I know I could divide it by 5 because the last digit is either a 0 or a 5. So perhaps we'll do 175 divided by 5. That gives us 35. Divide that by 5, and that gives us 7. Okay, so we have a group of 5s. Here we have x times x times x, and y times y. So here would be a group of y's, a group of x's. So we already have a 3. We're going to multiply that by a 5. And then we have an x and a y. What we don't have in a group would be our 7x. So that'd be 15xy square roots of 7x. Now we just want to check and see if we need absolute value signs. Okay, well, since both of these are odd and the root is even, we would need an absolute value. You can do an absolute value over both of them, or you could have individually. It wouldn't matter. Okay? Again, we have 2 and 12, and 2 and 6, and 2 and 3. Groups of 2. X, 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 and Y, Y. So here's a group, 2 groups of X. Here's a group of Y. So we already have a 6. Multiply that by a 2. We have an x squared that we can take out because we have 2 of these. That gives us our x squared, and then we have a y. And then square root of whatever is not in a group, so that would give us 6. So we have 12 x squared y square roots of 6. Okay, check for absolute values. All right, so since this y is odd and this is even, we have to have the absolute value. Okay, all right, now we're looking for groups of 3. So we could do 2 and 32, 2 and 16. We could do 4 and 4. Make groups. So here would be a group. Here would be a group. Oh, just kidding. I was trying to trick you. Okay, since it's a cubed root, we have to have groups of 3. So this would be 2 and 2, 2 and 2. Okay, so there we would end up having 1 and 2 groups of 2. Okay, and we have x, so x, 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 x to give us 6 x's. So we'd have 2 times 2 gives us the 4, x squared, and I guess that would be it. Okay, that's pretty good. All right, and yeah, I don't recall that working out so nice like that, but anyways, complex numbers. Okay, I am not going to go over all of these, but with the complex number system, we do the exact same thing. Basically, we're combining this and this. So when we have a negative, we take it out and have it be an I. Maybe we'll do this one, E. Okay, so we will make a factor tree. We could do 10 and 100. We could do 10 and 10. Okay, that would be a group. And if you wanted to, you could bring that further. You could do 2 and 5. Okay. All right, so we'd take the 10 out. Since it's a negative, we would bring it out and have it be an imaginary. Then we'd have a square root of whatever we have left, which would be 10. Okay. Sure, let's do 50. So here we could do 10 and 5, 2 and 5, group of 5. So we'd have 5. Negative will come out, make it be an imaginary, square roots of 2. Okay? All right, so let's do sums with variables. Okay, I think some of you guys liked I. Okay, so let's look at this. Factor tree. We could do 3 and 9, 3 and 3. Here would be one group. Okay, you could write down 10 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Groups of 2. But I mean, you kind of realize that it would be 5. And how do you know it's 5? Well, since this is a square root, what you really can do is divide it by 2, and that gives you how many x's will come out. Okay, so that would be 5 x's coming out. If we did it here, we'd get 3 and a half. So we'd have a remainder of 1. So we'd take 3 out, and the remainder would stay. So we'd have 1 still in there. Okay, either way you'd like to do it, that's fine. So you could do it this way too. Could do 7, that'd be 1, 2, 3, and one more. So groups come out would do 3, and then would have x to the 5th and y to the 3rd. And then we would have our imaginary. Okay, we take that out. Convention is that the I is always right before the square root. Okay? Or it's after all of this. So it's always between those two. Okay, and what we have left would be a 3 and a y. Okay, and you don't need absolute values, even though this is even and this is odd, because it's imaginary. All right, here I'll do a couple more. 5 and 5, take that out. We have x and x, that will come out. Y, 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 y. Y. Okay, those will come out. So it looks like everything's going to come out. We're going to have 5x y squared I. Okay, and that will come out too. This one, we could do 6 and 10. We could do 3 and 2, and 2 and 5. A group of 2 will come out. We can't make a group of x, but we can make one group of y. So we'll have 2yi, negative will come out, square root of 3 times 5. We have 3 and 5, so that would give us 15y. Okay, well, I think that was it. Next time we'll be doing operations. Okay, so if you have any questions, let me know. Hopefully this will be a good review from what you learned before. I think the only difference is the absolute value, okay? When you only do that when it's an even root and an odd exponent, okay? So since they're in order, I should probably write those in different orders, so it's always going to be odd, even, okay? So like here we have odd, even. Okay, all right, we'll see ya.